everyone, I'm Tin, and my advisor is Professor Zhang Jie. Before I started to introduce my research, let me ask you a simple question. How do you start your day? For me, the first thing I do is to check the weather on my phone to decide what to wear. After that, I'll go to school or go to work. I think many people have similar routine because according to X-ray, people now spend 80 to 90% of time indoors. Therefore, how to improve indoor environment quality is important for people's satisfaction. So my research topic is non-invasive human thermal comfort assessment based on real-time image recognition of clothing. Oh, it works. And first, I'll talk about what is thermal comfort and how to evaluate it, and my research purposes. And in the literature review, I'll talk about the research gap, and I'll talk about the methodology I plan to use in the last two parts. So first, X-ray defines thermal comfort as the condition of mind that expresses satisfaction with thermal environment. And the most widely used method is Fenger's PENG model. It integrates 4 environmental variables, including air temperature, air velocity, mean radiant temperature, and relative humidity, and 2 personal variables, including clothing insulation and activity level. It can predict an average comfort level of a large group of people. So if the weather is too cold, it will be the minus number from -3 to 3. So although the PENG model is widely used, the current method has its limitations. They use fixed personal variables. Take clothing insulation, for example. In winter, it's 1.0, and in summer, it's 0.5. Although X-ray provides some common types of clothing insulation, it is not enough because everyone wears the different clothes. So it's a lot more complex in a real world scenario. So the PENG model may not accurately reflect occupants' actual thermal comfort needs. So in my research, the research purpose is to analyze the clothing level recognition results in different angles and verify its accuracy. After that, I'll combine the weather data together because when I get up and I think today is very hot, and I will wear a short sleeve, right? So I'll combine the weather data to adjust the clothing insulation. And after I adjust it, I can calculate the PENG and compare it with the original ones. In the last part, I will design an experiment to validate its feasibility. And as thermal comfort research, it mainly in 3 parts, including experimental design, data collection, and modeling techniques. Next, I'll focus on data collection, including contact method and non-contact method. As you can see on the right side, the contact method is very invasive, so it will affect participants' willing to engage and raise some privacy concerns. So many research use non-contact method, and my research use non-contact method either, which use the video and the image techniques with the recognition techniques. So in non-contact method, in this picture, you can see some research use the infrared camera to explore the facial temperature recognition across multiple angles. From 80 to 100, you get better accuracy. But when the degree turns approach to 0 and 180, the accuracy will significantly decrease. And if I wear a short sleeve inside my shirt, the model can recognize it. So multi-layer is another problem. The literature review reveals the significant limitations in multi-layer and multi-angles. So we now know that people now spend 80 to 90% of time indoors, and we have multi-layer and multi-angles problem. So we divide our model into two parts. The first part is to train our clothing label recognition model. I'll analyze the recognition result in different angles. And in the weather AI model, I'll adjust the clothing installation. So I can calculate the PMV and compare it with the original one. Then I'll design an experiment to validate it. So as you can see, we collect 483 questionnaires. The X-ray is the outdoor temperature, and the Y-axis is the clothing insulation value. So as the temperature goes up, the clothing insulation will gradually decrease. So it means people tend to wear clothing with lower insulation at higher temperature to achieve comfort. And we use the deep fashion tube data set to train our model. We have 13 different types of clothing. And we use YOLO V7 to detection our clothing. And as you can see in the YOLO V7, there's a purple box. They identify it as a car, which is clearly incorrect, right? So in our model, we will first detect if there's a person in our image, then we will detect the clothing. So let's talk about the result. Take my shirt for example. Today I wear a long sleeve shirt. If the model tells me that I wear a long sleeve shirt, it's TP. And if I wear a long sleeve shirt and my model didn't tell me anything, then it means a true level is FN. And if I wear a long sleeve shirt and it tells me I wear a short sleeve, it not only means that I'm wearing a long sleeve, it also incorrectly detects the long sleeve shirt as a short sleeve. So it's FN plus FP. And how can we explain TN? I didn't wear a short sleeve, and the model didn't tell me that I wear a short sleeve. Then it's TN. So I put some images for illustration. So the first one, it correctly labeled the top and the bottom, so it's TP. And the second one, it missed a bottom, so it's FN. And as you can see, the degree is almost 0 degree. So the result is possible for it's more possible for FN. And the situation is FP plus FN. The difference between them is if they are zip up or not. Yeah. So after I have these classifications, I can calculate the recall and the precision of my model. The high recall means that the model can identify most of the clothing items they are actually present. And the high precision means that when the model predicts a specific clothing item, it's usually correct. And as you can see in our result, I compile it in 13 types. And there are some 0 and 1 value, which is shows that our model is not very reasonable. It is because we lack of data. We only have 483 responses, but our research is still going on. And the zip-up and non-zip-up situation is hard to recognize. And the future work will be divided into two parts. The first part is to collect more data, and the second part will be improving the model's performance. Thank you, and this is my reference.